All right, so today I am going to talk to you about whole numbers, how to add, subtract, multiply, and divide whole numbers. Let's first start with what a whole number is. So our whole numbers are 0, 1, 2, 3, 4, 5, and then we continue going. Um, Notice what happens when you get to the number 10. Well, you see it actually has two digits here. The first one being 1 and the second one being 0, which we already used before. And this pattern continues on and on until you get to three digits. Wait a minute, it's still the same pattern. We have a 1, a 0, and a 0. Well, this is because we have in our system of numbers, which we call decimals, meaning numbers based off of 10, we have our place values. And our place values tell us how many we have of a certain power of 10. For example, the number 32,768 has 8 ones, it has 6 tens, it has 7 hundreds, it has 2 thousands, and it has 3 10,000s. So as you increase a place value by 10, it then will start over at 0 again and increase the next highest power of place value. And this will continue on and on. So why do we need to review that? Well, we're reviewing that because in order for us to know how to properly add and subtract these whole numbers, and then even when we get to decimals, you have to realize how these change. And they change based off of the fact that the place values are based on powers of 10. So let's talk about that now. So our place values are based off of powers of 10 again. And so when we're adding them, we will increase the number in those place values by those same powers of 10. So let's start off though with ones because that makes things quite simple and that's what you first learn. So if I have 1 plus 2, I know that it's the same. If I'm starting at 1, I'm going to increase by 2 places. So if I was at 1, then I would go to 2, then I would go to 3 because that would increase it by 2 places. So just to show you on a number line, 1, 2, and 3, we will start at 1 and then we would increase 2 places. So 1 plus 2 is 3. And for many of you, this will be quite simple. And even still, because you learned it at a very early age, probably before you even actually got into school. So it's something that's been ingrained in you for a long time, and you've used constantly, time and time again, when just counting various things, counting how much money you have in your pocket, counting how many chicken tenders you got in that platter, how many French fries you ate at dinner, counting the number of teeth you still have in your mouth. Regardless, you have gotten used to adding because it's quite easy. And it's a simple thing that you use quite often. So what about when we get to things with, say, 1 plus 9? Well, when we increase by 9 from 1, or if we think of this as increasing from the number 9 and going up by 1, because these are the same, whether I do 1 plus 9 or 9 plus 1, it's still the same. So it's okay for me to move it around. But when I do this is 9 ones. When I increase it, I now have 10 ones. Well, when I write that, I can't have 10 ones because each place value has to go from 0 to the number 9. So I would put 0 ones, and I would have 1 10. So 1 plus 9 would be 10. If I were looking at 2 plus 9, I now am going to have 1 10. I know that already because I know if I go 9 plus 1, just going up by 1 more, I'm now looking at a 1 whole 10. And I have 1 extra 1 left over. So that's why 2 plus 9 is 11. Again, this is quite simple. I'm just repeating it and teaching it in this way so you can look at it as a place value, which it is. And this becomes more so important when it comes to estimating how much something is. For example, if I were to have the number 2,673, and we were to add to that 1,246, and I can very easily add this, but what if I wanted to get an estimate? So before I put this in the calculator or before I were able to present this to someone, I should probably have a good estimate of what this is going to be. Well, I could look at this as this is pretty close to 2,700 and this is close to 1,200. So I can look at this as approximately 2,700. And this symbol here means approximate. It looks like an equals. That's just wavy. And I can look at the 1,246 as about 1,200. And that's even easier for me to add. And so I would end up with 3,900. So I know my answer should be close to 3,900, maybe even closer to 4,000. So before I even begin adding, you should very quickly and mentally be able to come up with an estimate. And you will get some practice with this in your assignment as well. But let's add this to see what we get, to see if our estimate is accurate. So we have a 3 plus 6, which we know is 9. Now we have 7 plus 4, and 7 plus 4 is 11. So we will have the 1, 1, and the extra 10 will go to the next highest place value. So that's why they always said carry the 1 over, because it's going to the next level. Because if you wrote down a number 10, you will put down your 0 and then put the 1 in the next level, as we did earlier. So 1 plus 6 is 7, plus 2 more is 9. And then 2 plus 1 is 3. So we have 3,919, which is approximately 3,900. So that works. So if I were to have put this in the calculator and I got something, say, that was still 2,000, I should instantly know that, hey, I made a mistake somewhere. I must have made a mistake plugging this in because I know approximately what this should be. That is the reason why it's important to approximate these values. So we looked at how to properly add. Now let's look at the opposite or the inverse operation of addition. Let's look at subtraction. And I like to always think of subtraction as just being negative addition, just doing addition backwards. The reason being is because when you get negative and positive numbers, it's easier to understand what subtraction is. It's easier to understand what a negative number is because you're always looking at it as it just being the opposite or the inverse of doing addition, just going backwards. So let's talk about subtracting. So I'm actually just gonna put a random number up here and we're gonna see what happens when we do that. So we have 2,673 and we're going to subtract 1,789. So many of you were told that you first see if you can subtract this, 3 minus 9, and you can't. You won't get a whole number doing so because 3 is much smaller than 9. So you would go to the next level and borrow a 10. That is still accurate. That is the correct way to do it. It's the easiest way to understand how to subtract this by hand and what's happening here. So let's do that. So instead of 7 tens, this becomes 6 tens. And this now is 13 because we took the extra 10 that was in the next place value. And we could subtract that. I tend to teach people the way that I understood this more once I noticed the pattern happening. I like to go all the way over and see if there's anything else that will need to be borrowed for later. And I like to do that all at once instead of having to subtract down, go to the next one, subtract down, go to the next one, subtract down, go to the next one. And I'll just show you both so that you can decide for yourself what you would like to do. Because the point is for you to find a method that you like, that's going to be easy for you to understand. So if I were to do and continue here using the traditional method that you were taught, I would say, okay, well, 13 minus 9 is 4. And I would go to the next level here. And I have 6 minus 8. So that means I'll have to borrow once again because 6 is still smaller than 8. So I'm going to borrow from the next level, and this 6 will become a 5, while this 6 becomes a 16. And now I can subtract. So 16 minus 8 will be 8. And now I go to my next level, and it says 5 minus 7. Once again, I can't do that. So I must borrow from the next level. So I'm going to borrow from the 2 over here, and it becomes a 1. And this 5 now gets an extra 10, so it becomes a 15. So 15 minus 7, I can do, and I get 8. Okay? So there were a couple of steps that happened while subtracting that. So I'm going to redo the same problem, but using the method that I was referring to. So 2,673 minus 1,789, once again. So I know that 3 is smaller than 9, so I'm going to have to borrow. So I'm going to come over here, and I already know that 7 is also smaller than 8, so I'm going to have to borrow. I already know that 6 is smaller than 7, so I'm going to have to borrow. So I'm going to start over here, and I'm just going to go ahead and borrow and bring it over here. So that's 16. And I know I have to borrow for the next one. So that's going to be 15, and this becomes 17. And I know I'm at the borrow over here, so that's 16. And this is going to be 13. And so 13 minus 9 is 4. 16 minus 8 is 8. 15 minus 7 is 8. And we already know 1 minus 1 is 0. So I ended up with the exact same thing, 884. But this method, I already know ahead because I have good number sense that these numbers are going to be smaller, so I have to borrow from the next level. So I went ahead and started from the first place that I actually needed to borrow from, finished borrowing all the way through, and then I just subtracted down. So to me, that makes things a lot easier. For some people, the traditional method is what they're used to, and it's easier instead of learning something new. You decide for yourself what you would like to do. Okay? All right. So that's subtraction, which is just negative addition. If you have trouble subtracting with the whole numbers, another thing you can think of is how far apart are these numbers on the number line. So we have an example up here of 13 minus 9. So how far is 13 from 9? Well, how far is 13 from 9? There's 1, 2, 3, 4. They are 4 away from one another. So that's all subtraction is, looking at the difference or how far apart numbers are from one another. You can also, as I said earlier, think of it as the opposite of addition. So in other words, if I'm doing 13 minus 9, I would say 9 plus what gives me 13? 9 plus what number gives me 13? And the answer would be 4. This is another way to think of how to do subtraction. This also helps because when you get to solving equations, it makes it a lot simpler if you're already in the format of thinking this way in your head. For those of you that have children doing Common Core, or those of you that have heard about the Common Core training method, these two are more closer to what they teach. And the reason is so that students excel further ahead. It's not just a new thing so people can freak out about or be mad about. The traditional way we learn, there was nothing wrong with it. We learned it. It's very useful to us. This is just so that there's a higher order of thinking when doing mathematics or any subject that's Common Core is being taught correctly in. So if you want help with how to help your children with the Common Core math and getting to understand it because you have your traditional ways, take a look at how the textbook does things. You can ask Tutoring LRC. You can ask me if you have any questions about that, aside from class, of course, because doing the class is what's important. at the moment. But there are lots of resources on that. I kind of just threw that in there because I just thought about it, because a lot of times people don't like to do things differently, which is fine. You find your method that you like, as long as it gets you to the truth and to the real truth, then do that method. So that's subtraction. Now I'm going to do an example with multiplication. So multiplication. So multiplication is just going to be repeated addition over and over again. For example, instead of saying what's 2 plus 2 plus 2, which is quite simple for most people, they'll say, okay, well, 2 plus 2 is 4, plus 2 more is 6. Okay? But what if things continue on in that fashion for much longer? At that point, it becomes not difficult, but just tiresome and tedious to add those numbers together. So that's why we have multiplication. It makes doing addition much faster when you have repeated addition. So instead of 2 plus 2 plus 2, we can think of this as 2 times 3. Now in this course, you may see sometimes in formulas a dot between things, meaning to multiply it. You may see parentheses around the second number. You may see parentheses around the first number, or you may see parentheses around both numbers. All of these mean to multiply. You also have the traditional way, still in some formulas used. We have 2 times 3, and the multiplication is symbolized by a small x. I tend to not use that, and nowadays that is least likely to be used because that takes away another variable that we can use, because we can use x as a variable to stand for something that you can substitute into a formula. And we'll talk more about that in a future video. So we have 2 times 3, and when you were in school, maybe you learned you had to do a multiplication table or a times table. That is great. If you remembered all that, that is excellent. It'll make doing multiplication a lot easier and a lot quicker. If not, there are a lot of tricks and things that you can learn to make it easier for you. For example, multiplying times 2 is just doubling. So it's easier for some people to say to do what is 3 doubled than to say what is 2 times 3. Not really when it comes to the number 3, but more so when it's a larger number. It's easier to think of, well, how do I double this number, as opposed to what's 2 times the number. So anyway, 2 times 3 we already know is 6. All right. But when you have just single digit numbers multiplying, that has always tend to be a lot simpler for people. Why? Because they were able to remember it or memorize a multiplication table or some other form of such. So what about when we have larger digits? Well, I am going to show you three ways on how to multiply with larger digits. The first one is going to be the traditional way. And so I'm going to use the number 631, and we're going to multiply this by 7. And we're going to do it the traditional way. So here's the traditional way of multiplying. So you first said, well, 7 times the ones place, so we can find out how many ones we have. 7 times 1 is just going to be 7. Then the next thing you did was you would say, okay, well, 7 times 3, I'm looking at how many 10s I have. 7 times 3 is 21. Well, what you would do, you would put the 1 down in that 10 slot, and you would say, well, since it's 21, that 2 is going to have to go to the next level. So I'm just going to put it up here to add on to whatever I multiply. Okay, so 7 times 6 is 42. And then we would add that extra 2 that we got from the previous place value, and we would end up with 44. So traditionally, when we multiply this, we end up with 4,417, which is accurate. Now, before we started this, we could have estimated. So we have about 600 times 7, And 6 times 7 we know is 42. So I'm going to write down how we can approximate here. So we have 600 times 7, and then 6 times 7 is 42. And the cool thing about multiplying when you have zeros at the end of your numbers is you can just bring them down. And so we get somewhere close to 4,200. We know it's more than that because 631 is more than 600, which is what we got. So we did this problem most likely accurately, which we did. You can check with your calculator if you don't believe me. So that's the traditional way we learn how to multiply. And you don't always have to do the estimation or write it out, but in the beginning, it's good so that you get used to doing estimates in your head. Because when we get to higher level formulas or formulas that have more going on, it's good to have an estimate so you know, okay, yeah, my answer is most likely right. Okay, so that's the traditional method. I'm going to show you the expansion method next. All right, so with the expansion method, what you would do is instead of doing all of this as one whole thing, you would separate it. So we would have 600 plus 30 plus 1. And each of these separately is going to get multiplied times 7, and then we'll add it up. So the reason why people like this is for what I said earlier when I was doing the estimation. When you have zeros at the end, it's much easier to multiply because you just need to multiply the two numbers that aren't zero and then put zeros everywhere else at the end. So 7 times 1 is still 7. And actually, when I do this, I like to start in the beginning because it doesn't matter which order you do. It just looks better when you start in the beginning. So 7 times 600 would be 4,200. Okay, that's easy. 6 times 7 is 42. Put the 2 zeros at the end. Next, we have 7 times 30. 7 times 30 is 210 because 7 times 3 is 21. We have 1 0, put it at the end. And then 7 times 1 is 7. So when I add this, notice how I wrote this. Everything's quite easily in order. And what do we have to add? A lot less. A lot less. It's generally just going straight down. So we have a 7, a 1, a 4, and a 4, and we're done. Now on paper, that may look like we did more because you see more lines. But we did the exact same thing we did in the traditional method. Actually, quite literally the exact same thing. The only difference is we added the extra 2 over here. We added in the hundreds column instead of having to add it mentally here when we just multiply. So that's one reason why this method is seen to be better. Now, the last method I'm going to show you is actually really the exact same as the expansion method. Only difference is that you can expand things however you want because the number 10 is the same as, or sorry, let's say this instead. The number 11 is the same as 10 plus 1, but it's also the same as 5 plus 6. And some people may be more comfortable multiplying with 5 plus 6 than 10 and 1, or whatever numbers that you may have. So if it was like number 17 is 10 plus 7. That may be easy for some, but 7 may not be. So maybe they may change it to 10 plus 2 plus 5 because all three of those numbers are quite easy to multiply with. So let me show you an example of what I'm referring to here. So the next method is called an area model. And the reason most people like this, and even nowadays students, younger students are taught to multiply in this fashion, the reason being is because the concept of area is widely known. Area is length times width. And that concept is so widely known, so widely used, so easy for most people to understand. Why not use it when multiplying whole numbers and integers so that people feel more comfortable doing so. So the way you would do that, as I said, it's really just the same as the expansion method. So we have 631 times 7. So I'm going to say that this side is 7 of this rectangle I drew. And I'm actually going to break my rectangle up into 3 parts. So I have 600, I have 30, and I have 1. Why do I have that? Because 600 plus 30 plus 1 is going to be what? It's It's going to be the 631 that we're multiplying times 7. Did I have to break it down this way? No. As I said before, like with the example of 17, you could change that to be 10 and 7 or 10 plus 5 plus 2, because that may be easier for you. So let's multiply now. 600 times 7 is going to be 4,200. 30 times 7 is going to be 210. And 7 times 1 is 7. And usually at this point, most people can, when they see it written out this way, I'm actually not quite sure why, but seeing it written like this is sometimes harder or takes more time for people to add than when they see it written in this format. Maybe it's just because of the area model, you know that, oh, all that has to come together. I'm not quite sure why, but it is usually easier for people to add it, and they'll automatically will just usually say, oh, that's going to be, oh, yeah, that's 4,417. So those are our 3 ways to multiply whole numbers. All right. Now, let's go on to the next thing, which is just the reverse of multiplication, and that's going to be division, similar to how subtraction was the reverse of addition. So I'm going to do some division now. And the great thing about division is that whenever you were dividing, you were always estimating. When you learn it traditionally in school, you always estimated because you had to figure out what the quotient was based on an estimate. And if it didn't work out, you would go back and change it. So I'm going to use a simple number here. Let's use 441, and we're going to divide it by 3. Now, this is the traditional way that you were taught to write division in school. And that is completely fine. And I completely understand that. Most time in formulas, however, you won't see this written this way. You won't even see it written this way. So I'm going to write it the way that we tend to write that we want to do division nowadays. So instead of writing it using the bar and the bar with the 2 dots, I'm going to write it like this. Wait a minute, that's a fraction, right? I remember that. That was fractions. I didn't really like that in school. No. Fraction is really just division. They realized that they could divide these whole numbers, and they needed a way to represent that when they didn't get a whole number as an answer. And that's where fractions came from. We'll talk more about that in the next video. But this is just division, and this is the way that you will see it written in formulas. You will see a numerator with a denominator. And again, we'll talk more about what those are in the next video. But let's divide now. This may make it seem like it's harder for some people to do the division, but let's just look at it at the place values that are there, because that's really what you did. You always just looked at the place values. You always started with the left side. Why? Because that was the highest level. Well, when you multiply, then you start off with the ones place. You did. You started with the ones place. And actually, it doesn't matter, but it's going to be easier if you start from the highest place value. Why? Because division, again, is the reverse of multiplication. In multiplication, you started with the right side or the lowest place value and worked your way up. So division, going reverse of multiplication, we'll start at the left side, the highest place value, and work our way back. So if we start here, we have 400 divided by 3. 400 divided by 3. And a good estimate from that would be, so actually, I'm going to write out what I'm talking about here. So let's look at 400 divided by 3. We know that 400 divided by 3 is approximately what? 100. Okay. Some of you may say 130. Some of you may say 110. Some of you may say 120. Doing it this way won't really matter, because if it is going to be 100, then we know that how much is going to be left over for 400, because 100 times 3 is 300. We know that we will have a remainder of 100. So we're going to take the 441 divided by 3. We're going to take out 400 of that, and we're going to be left over with an extra 100. So we now have 141 divided by 3 because we already did 400 divided by 3 and we approximated it to be 100. So the next part here, we're going to do 141 divided by 3. And you may approximate that and say, okay, well, I know if I'm looking at about 140, I could use what? What would be a good estimate to use? Well, a good estimate to use, let's just say you say, okay, let's just say you go with 30. Say you don't even think, well, 120 would be a better estimate. Let's just say you say 90 will be the best estimate you can come up with. That's fine. There's nothing wrong with that. So if you were to do that, you know that 90 divided by 3 would be 30. So we'd have 30 more. And we take 90 away from this guy. And we would have 51 divided by 3. Because we already took care of doing 90 divided by 3. So I have 51 left over. Okay, well, 51 divided by 3, maybe you already know what that is off the top of your head. Maybe you don't. What do you know that's something that you can divide by 3 that's going to be less than 51? Let's say maybe you know 30. Okay, well, if we know 30 divided by 3 is 10. Okay, and we took 30 away from that, we would be at 21. And we know 21 divided by 3, we used that earlier, and that's 7. So using this method, it doesn't matter how you estimate it. You don't have to find what's the highest number. You can add all of these together, and you end up with 147. And so if you do 441 divided by 3, you end up with 147. So that's one way of doing division. If it's going to make it easier for you to write it in a traditional sense, do that. And so I'm going to show the exact same question using the traditional sense to make things more comfortable for some of you. So if we did this, we would start here, and 3 would go into 4, or 4 divided by 3 is what? And we would say that's a 1. And we would multiply down 1 times 3, and we will get 3. And we would subtract, and we would get 1. And then we would bring down the 4. And now we would say 14 divided by 3, a good approximation of that. We would then say the best approximation is going to be 4. If we had put 3 here, we would have noticed that we were wrong and we had to go back up using this method. So 4 times 3 is 12. You would subtract these two numbers, you get 2. And you would bring down to 1. And then we would say, well, 21 divided by 3 is what? 7. And 7 times 3 is going to be 21. And we will subtract these two numbers, and we will get 0. And because we have a remainder of 0, and this number is less than 3, we are done dividing, and we know that 441 divided by 3 is exactly 147. Okay? The great part about having this stuff on video is that you can go back and pause whenever you like, or look over these things again. So that's it with the whole numbers. That's adding, subtracting, multiplying, dividing with the whole numbers. The only other thing that you may need to do with whole numbers, we'll talk about towards the end of this video. So we're going to look at this in terms of integers now, because whole numbers were from 0, 1, 2, 3, 4, and so on and so forth. But when we came into, hey, can I borrow $5 from you? Sure. Well, now I'm in debt to that person. That person's down $5. So how much I owed them before was 0. I never owed them any money. Say I already owed them money. Let's say I borrowed money from you, and I owe you $5. And then I borrowed another $5, and now I owe you $10. Well, my balance with you started off at 0. I owed you nothing. We were square, we were clean, we were even. Then I subtracted $5. I took $5 from you. I borrowed $5 from you. So I subtracted $5 from you. And then I subtracted another $5 from you. So I'm starting to owe you more of my money. Instead of writing a balance of $10, which makes it seem like I have $10 with you that you need to give me, they had to come up with a different method of writing this. And so what they decided to do was, knowing that this was just $10 that I owe, instead of writing 0 minus 10 on their balance sheets or whatever they had back then, they were usually like chiseling on stone. It would have been easier for them because they sometimes had a lot of numbers here. It was much easier for them just to write -10. And that's where these negative numbers came about. They understood that they were on the other side of 0. They were looking at the negative sense. But they didn't want to have to keep writing 0 minus all the time. So that's quite funny, I think. But regardless of that, now we have these new numbers that we have to use, and they still have to work with the order of operations we have. So you still have to be able to add them. You still have to be able to subtract them. You still have to be able to multiply them. You still have to be able to divide them. So how do we do that? Well, let's talk about adding them. So first of all, let's say we're just adding two negative numbers together. Well, it's similar to my first example when introducing negative numbers. -10 plus -5. Well, what is that? What is -10 plus -5? Well, I owe someone $10 and I take 5 more from them, so I still owe them another 5. So I owe them 15 in total. So I owe $15, so -15. So as you notice, what are we doing when we're adding two negative numbers? We're just adding the numbers and putting a negative there. So -21 plus -2, we add 21 and 2 together, and we get 23, and we put the negative sign. And that's it. It's quite simple. So what about when we have a negative number and we're adding a positive number? So here's where things change. They had to have a way to add these properly, because now I owed you $10 and I gave you 5 back. How much do I owe you now? Oh, that's quite simple. You only owe me $5 now. Well, how do I think about this when I'm just adding a negative and a positive number? Well, if you're adding opposite signs here, so if you're adding a negative and a positive together, you first subtract the numbers, and then you put the sign of the larger one. So if you're adding a negative and a positive number, you first subtract the numbers, and then put the sign of the larger. All right. So let's throw another number out here. So -21 plus 17. 21 is larger than 17. So our answer is going to be negative in the end because the larger one is negative. And then we could just subtract these two numbers. 21 minus 17 would be 4. Okay, simple enough. Going in the other direction. So let's say I had 25 plus a negative 13. Well, 25 is the larger number, so our answer is going to be positive. And 23 minus 13 is just going to be 12. And so that's how you would add integers. Integers just means positive and negative numbers plus 0. All right, so that was adding. Now let's look at the more difficult one for most people, and that's subtracting them. Well, we said earlier that subtraction is just looking at the difference or how far apart two numbers are from one another. So the same thing holds here with integers. The rule of subtraction never changes. Still how far apart numbers are from one another. So if you continue to think of it in that sense, it'll actually make this quite easy. So let's just say we have -10, and we're going to subtract -5. Well, they're both on the negative side, right? So we can still think of it as if it was two positive numbers, and it still makes it quite simple. So how far apart is negative 10 from negative 5? Well, they're just 5 apart, right? If I had my number line, I have negative 10, negative 9, negative 8, negative 7, negative 6, negative 5. How far apart is 10 from negative 5? It's quite simple. They're still just 5 apart. Now, we're on the negative side of this though, right? Yeah, we're on the negative side of this. So our answer is going to be negative 5. All right. Well, another way to think about this, and this is the way that it's generally traditionally taught, is subtraction, once again, is still negative addition. Well, how about we just write that? So negative 10 minus negative 5, instead of leaving it as a minus, let's change it to negative addition. So that means we have negative 10 plus negative 5. Well, I don't know if you heard the saying that two negatives make a positive. Well, that's right. If I say that this is not negative 5, then you would say, okay, it must be positive 5 then, right? If I asked you to not do something, you would say, okay, I guess I'm supposed to do it. So, in other words, this becomes a positive 5 now. And we talked about earlier how to add those two numbers. You take the sign of the larger one, and you subtract the two numbers. So once again, we end up with negative 5. Okay. Other times I've seen people say that if you have a minus, change it to a plus and change the sign of the second one. So that's another way of writing it, and that's another way of saying it. And this is generally, honestly, what I do myself. I just quickly say, okay, well, I'm going to make that plus and change the sign, and then work from there. So either way, you still get negative 5. But that was two negative numbers subtracting from one another. So let's look at this differently. Instead of negative 10 minus negative 5, let's look at it as negative 5 minus negative 10. All right, how far apart are negative 5 and 10? They're still 5 apart, right? Still 5 apart. But this time we're moving to looking at it in a positive direction. And since we're looking at it in a positive direction, this answer is going to be positive. That's if you're using the number line. Now, if we're not using a number line, say we're using the other way we just talked about, negative 5 minus negative 10, we would say this is negative 5 plus 10. Okay. Well, 10 is the larger of the two, so our answer is going to be positive, and then 10 minus 5 is 5. So as you can see, once again, this method is probably easier to understand and a lot faster to compute with. So what about when we have a negative and a positive number subtracting? So let's do negative 10, and instead of keep using 5, let's use 3 this time. So negative 10 minus 3. Well, how far are negative 10 and 3 from one another? Well, to get the negative 10 to 0 is 10, and to get from 0 to 3 is another 3, so that's 13 in total. And we're looking at it in a negative direction, so it's going to be negative 13. Using the method we just talked about, though, negative 10 minus 3, we can say negative 10 always changes to addition and change the sign of the second one. So negative 10 plus negative 3. Much easier to look at, much easier to do, because we know we have the same sign here. Our answer is going to be negative, and we just add the numbers together, and we get negative 13. Okay. What about if it was the other direction? What if this was 10 minus a negative 3? So we still have a positive and negative, but now the positive is the one in front. So we can still do the same thing. Let's change the sign of the second one. And so we went from a minus to a plus and changed the sign negative 3, so this becomes positive 3. And 10 plus 3, we've seen that long before we ever saw a negative number exist. So this was 13 again. So if we were to think of this as how far apart are these numbers, Well, how far is 10 to negative 3? They're 13 apart, and we're looking at the positive side of it, so it's 13. So you can always look at it in a number line sense, and honestly, that usually helps best when it comes to estimating. But changing the sign of subtraction automatically to a positive or to a plus, and changing the sign of the second number, so if it was negative, turn it into positive. If it was positive, turn it into negative. That usually helps a lot when it comes to subtracting with integers. So that was subtracting with integers. And now let's talk about multiplying integers. So multiplying integers and dividing integers, we can talk about both of these at the same time actually, is no different from what we did with whole numbers. The only difference that comes up is if you have a negative times a positive or a negative times a negative, what kind of answer do you have? Do you have a negative answer or do you have a positive answer? And it's quite simple rule here. And we actually we already talked about it earlier. If I tell you to not do something, you think, okay, well, I'm going to do it then because that's what he wants, right? Because it negates the negation. Same rule applies here. So if I have a negative 5 times negative 2, I know 5 times 2 is 10, and I'm saying negative of a negative, so that makes it positive. So my answer is just 10. If I were to have negative 5 times positive 2, I know 5 times 2 is 10, and I have a negative here. So this says my answer should just be negative because there's nothing to change that. So it's negative. If I were to do 5 times negative 2, 5 times 2 is 10. And this says keep it positive. This says no, negate it. So we're going to negate it. So it's negative. Right? So what you notice here is that every time you multiply negative times negative, it turns to positive. And every time you have a negative with a positive, your answer is negative. That being said, here I have 3 negative numbers multiplying. So 5 times 3 is 15 times 2 is going to be 30. Okay, well, let's look at the signs. We have a negative times a negative, so we know it's positive, times a negative, so it becomes negative again. So this is negative 30. So in simpler terms, though, if we want to figure out what the sign is, see how many negatives you have. If you have an even number of negatives, so like you have 2 negatives, or 4 negatives, or 6 negatives, or 0 negatives, your answer would be positive. Why? Because if you take 2 negatives and multiply, it becomes positive. And we already know what happens when you do positives times positives, it stays positive. When you have an odd number, however, the even ones will cancel out, but you'll still be left over with an extra negative. It just will always happen. So if you have an odd number of negatives, your answer is negative when you're multiplying or dividing. If you have an even number of negatives, like we had in the beginning, your answer is positive. All right, and let's just see it with division so that you're comfortable with it. So let's do 132 divided by 3. Okay. So 132 divided by 3. Well, let's see. I know that actually we need to have a negative here so you can see that it doesn't matter. So let's do 132 divided by negative 3. So we already know our answer should be negative, right? Okay. And I'm going to use the method that I was talking about before in estimating here. So we know that 132 divided by 3, if I think of it as in hundreds, 100 divided by 3 is going to be close to 30. I don't have to get that much closer, but I can do that. So I just used 30 times 3 of it, so that was 90, so I have 42 left over. So actually, I'm going to take note up here so that you can see what I was doing. So we just estimated with 100 divided by 3, and we got 30. And so when we did that, we know we actually just used 90 out of the 3. So 90 out of 132, we have 40. We have 50. Excuse me. We have 42 left over, and so 42 divided by 3. Maybe I still don't know what that is. Maybe I'll just say, okay, well, we're going to use 30 of it, and 30 out of 3 is 10. Well, now I have 12 left over, and that's quite simple to do. 12 divided by 3, that's going to be 4. All right, and so 132 divided by 3, we end up with 44. But remember, we had one negative here, so our answer is going to be negative 44. All right, let's look at a different one here. Just again, very quickly, let's do negative 91 divided by 7. Negative 91 divided by 7. All right, so if I were to do this, I know I have one negative, so my answer is going to be negative. And I need to do 91 divided by 7. Let's just say I know off the bat, well, I can do 70. So let's do 70 divided by 7. 70 divided by 7 is what? It's going to be 10. So if we take 70 out of 91, we're left over with 21. And 21 divided by 7 is 3. And so we know our answer is going to be negative 13. Okay? So that's division and multiplication with positive and negative numbers, so with integers. If we were to have two negatives dividing, it would turn to positive, as we did earlier with the multiplication. So if you have an even number division, you end up with a positive answer. If you have an odd number of negatives with division, you will end up with a negative answer. So the last thing is order of operations. So many people call it PEMDAS, which is fine. It helps people remember how you properly do order of operations. And the reason for order of operations is so that we have order. So there's no confusion of a way how to use these operations with these numbers, and so that everyone will always and should always get the same answer whenever given an exact same problem. Otherwise, confusion, and confusion is never good. So if you're confused, you should always contact your instructor or ask someone for help, because you want to make sure you're clear on things so that you do things correctly. So let's do order of operations quickly with integers. So order of operations, our order of operations are going to be parentheses, exponents. Remember, exponents are just multiplying and dividing. Exponents are just going to be taking a number and multiplying it times itself several times. So parentheses, exponents, and we'll do multiplication or division. Because remember, division was just the reverse multiplication. So they're on the same level. So the way you handle problems that have both is you work it left to right. So this is from the left to the right. And then we will also do addition and subtraction similarly, looking at it from left to right. All right. So with that being said, if I had a problem that was 3 plus 2 to the second power minus 3 plus 6 divided by, let's do 2 times 1. And yes, I said we won't be using the symbol. I'm just putting it here just to help out and move along. We will first do parentheses. And in parentheses, I have 3 plus 2. And 3 plus 2 is going to be 5. So we have 5 squared minus 3 plus 6 divided by 2 times 1. All right. The next operation is exponents. So I would do 5 to the second power, which should give me 25. Minus 3 plus 6 divided by 2 times 1. All right. Well, my next operation is subtraction. No, it's multiplication or division, whichever comes first. So in this instance, I have multiplication and I have division. What do I want to do first? I want to do the division because we're looking at it from left to right, because that's how we read. So we have 25 minus 3 plus 6 divided by 2 give me 3 times 1. Multiplication is going to still come before that subtraction. So we get 25 minus 3 plus 3. Subtraction comes before the addition, going from left to right here. So 25 minus 3 will give us 22 plus 3. And we end up with 25 as our answer. All right. So that's order of operations. Let's look at it one more time with the same problem, but instead we are going to add some negatives in here. We're going to see what happens when we do that. So I'm going to make this a negative 1, and let's make this a negative 3, negative 2 here, and I think that'll be good enough for the example. So let's do parentheses first still. So 3 plus negative 2. Actually, I'm going to change that. I'm going to change that to a negative 3. So negative 3 plus 2. Well, we said earlier that we're adding two different signs here. What you do is subtract the numbers. So 3 minus 2 is 1. And you take the sign of the larger one, which would be negative, because 3 is larger than 2. It was negative. So negative 1 squared minus negative 3 plus 6 divided by 2 times negative 1. Okay, so we do parentheses first. Now we do exponents. And actually, the reason I changed the sign is because I want to show you that negative 1 times negative 1 squared is going to be a positive 1. Most time, people will enter negative 1 into their calculator, and what happens is they don't put parentheses around negative 1. And so instead of doing negative 1 squared, it does 1 squared times a negative 1, which makes your answer negative, which comes out wrong then for you doing this problem. So if you have a negative 1 squared on your paper or in your problem, you want to put parentheses around the negative 1 so that when you're inputting in the calculator, you know you get the correct answer. This is also why it's important to use that number sense, because we know if we take a negative times a negative, we should end up with a positive. So if you're in your calculator negative 1 squared and you end up with a negative number, you shouldn't say, oh, well, maybe I was just wrong about that. No, that rule is still intact. Negative times a negative should give you a positive. So you must have entered it in wrong. This is the biggest and most common mistake that students make, and it generally will cause them to get the wrong answer, and they never know why. So if you see a negative number that needs to be raised to a power, and you see that it's supposed to be the negative number raised to a power, make sure you put parentheses around that negative number. So negative 1 squared, or negative 1 times negative 1, would be positive 1. And going in order of operations, left to right, we're going to do the division next. And then 6 divided by 2 is still going to give me 3. Okay. Multiplication next. So 3 times negative 1 gives me negative 3. All right. Go in order from left to right with subtraction and addition. So subtraction next. So 1 minus negative 3. Like we said before, you can change the minus to a plus and change the sign of the next term. And we end up with 1 plus 3 is going to be 4. And last but not least, 4 plus negative 3 is going to be 1. Why? The larger of the two is a positive, so our answer is positive. 4 minus 3 is 1. And so we end up with 1. And that is a review of adding, subtracting, multiply, dividing in order of operations with integers. So those were our negative numbers, 0, and our positive whole numbers. All right. So if you have any questions or you would like further review on this topic, please feel free to contact me. And you have my email at christopher.stevens@southmountaincc.edu. And I am here to help. I will be loading up more and more instructional videos for each chapter as we continue on with the semester. And if there's anything that you want me to clarify and that you see in any of the videos, please feel free to ask. If you feel comfortable with working ahead without looking at the videos, that's absolutely fine as well. Because the point of the videos is just so you have something else to go back to. So you have some kind of instruction to go back to while you're working through these chapters from home. All right. I will see you next time.